Hello friends, welcome to Catalyst Chemistry. Haloalkanes, haloarene almost completed, but in this case we are going to discuss some of the important points are there still, that is what nucleophilic substitution reaction. Nucleophilic substitution reaction, these questions they are not going to ask in mechanism, they are not going to ask in examination, but what I wrote on the board is some points maybe they are going to ask you in examination PU board. Okay. But mechanism also important. In this case mechanism means that is completely depends on what electron withdrawing, and next one is what electron donating. Which group is the electron donating and which group is the electron withdrawing, that point we have to remember and practice, bear in mind. Okay. Automatically this group is electron withdrawing, this group is electron donating, it is not possible to say, but you have to remember, take a note and make it perfect, that is most important. For example, NO2 is there, Cl is there, Cl is also electron withdrawing group, NO2 is also electron withdrawing group, hydroxyl is there, OH group, that is electron donating group. I will clear in this video which group is act as electron withdrawing group and which group has act as a electron donating group. So far I told in a electron donating, electron withdrawing examples, in that point you have to remember. Okay. In this case we are going to study about what mechanism, how does it work. Okay. Just see here friends, title is what nucleophilic substitution reaction of chlorobenzene. You know very well about that haloarenes. Haloarene means what, the benzene ring attached to chlorine, fluorine, bromine, iodine, etc. That is indicate what, haloarenes. Okay. Haloarenes are extremely less reactive towards nucleophilic substitution reaction. This point you know very well about that. In that case you are going to get a 4 reason. Okay. 4 reasons are most important. Okay. That is why you know very well about that nucleophilic substitution reaction extremely less what for what, haloarenes. Okay. Just here, but in this case some of the reactions are there, some of the reactions can undergo what, nucleophilic substitution reaction. Just here the first reaction. Okay. This reactions already I told in one video, but here is I am going to make it repeat. Just here, what is the name of this one, chlorobenzene is there. Okay. If you want you can write name here, no problem, chlorobenzene. Okay. Chlorobenzene, this is the sodium hydroxide. The sodium hydroxide in this case what most important is, this is act as a what, nucleophile. This is act as a what, nucleophile, because aqueous sodium hydroxide is there. Okay. If alcoholic is there, what, that point is what, different, act as a base. Okay. Just here, this is a chlorobenzene. Our target is what, this is a haloarene. Haloarenes are extremely less reactive towards a nucleophilic substitution reaction. Okay. This is what, Na plus is there, next this is what, OH minus is there. This OH minus is not possible to attack on this chlorobenzene, that is a rule. But in this case we are going to maintain some conditions, then only this haloarene can undergo nucleophilic substitution reaction. What kind of conditions are there? Just see here. Just here, in this case they are going to maintain temperature 623 Kelvin. After that they are going to maintain what, 300 atmospheric pressure. Then only this haloarene can undergo nucleophilic substitution reaction. If you are not going to maintain such kind of condition, haloarenes will not undergo nucleophilic substitution reaction. This is a basic funda, that is why bear in mind, important. Okay. That is just here, this OH minus is going to attack on what, this position, the Cl will go out directly. There is a formation of product is what, the product name is what, phenol. The product name is what, phenol, plus release of what, NaCl. The Cl will go out, act as a Cl minus. This is a mechanism. This is the what, reaction of what, nucleophilic substitution reaction for chlorobenzene. Bear in mind, okay, important condition, must and should you have to maintain condition, high temperature in this case. Just here, the next one is most important point, the presence of, just listen here carefully, the presence of an electron withdrawing group like NO2, presence of an electron withdrawing group like NO2 at ortho and para position increases the reactivity, that is most important point. Just here, if electron withdrawing group attack on a benzene ring, means haloarene, automatically the reactivity is going to increases. Next question, why reactivity is going to increases? Just here, here is don't worry about this part. What is the name of this one? Tell me. Chlorobenzene. This NO2 attack. This NO2 is act as a electron withdrawing group. Electron withdrawing group means in this case, this is in this case what electron density more on the what benzene ring. This NO2 withdraw electron towards itself, that is indicate what electron withdrawing group. Okay, this is what only one electron withdrawing group is there. This can also undergo nucleophilic substitution reaction. Just here first point they are going to add a NaOH. The NaOH means this OH minus is act as a nucleophile. After that they are going to maintain temperature 443 Kelvin temperature. Next they are going to maintain what acidic media. H plus indicate what, that is acidic media. This is 443 Kelvin. Automatically what happens, the Cl will go out, the OH is going to attack on that position or that carbon. Automatically there is a formation of product. Just here compare with this one and this one. In this case there is no electron withdrawing group, that is why they are maintained high temperature, but in this case one electron withdrawing group is there, that is why they are going to maintain low temperature up to 443 Kelvin. This is a fact. Okay, that is why bear in mind. When you are going to increase the number of electron withdrawing group, automatically temperature is going to what, less. That is the what most important. Bear in mind, most important, what you are going to call, this is most important means in this case para-nitrochlorobenzene, para-nitrophenol, you can write, no problem. The next second part, in this case second part, just here Cl is there, one NO2, second NO2, two NO2 groups are there. These two are indicate electron withdrawing group only, but in this case how many NO2 groups are there? Only one, but in this case how many are there? Two electron withdrawing group is there, automatically the reactivity is going to increases. Here is there the presence of an electron withdrawing group at ortho and para position increases the reactivity. If you want, you can add one more point, more number of electron withdrawing group present on the haloarene, automatically the reactivity is going to increases. Okay. That is why in this case how many NO2 groups are there? Two NO2 group. In this case what, only one NO2 group is there. Okay. First point NaOH, they are going to maintain less temperature 368 Kelvin. Next one is what, H plus. In this case what is the temperature? 443 Kelvin, but in this case what, the temperature is less, that is up to what, 368. In this case also there is a removal of what, Cl by what, OH. Bear in mind, important. Okay, don't take it easy. Okay, you have to better make it round off, you will get an idea. Okay, just see here. Okay, if you want to do like this, definitely you will remember. You have to take different ink pen, automatically you will notify very easily. The Cl is removed by OH, the remaining is as it is. In this case also the Cl is removed by OH, the remaining things is what, as it is. Okay, that is why in this case they are going to maintain 368 temperature. Why they are going to reduce the temperature? Because the more number of NO2 groups are going to add, automatically the temperature is going to less, because these two act as electron withdrawing group, automatically the electron density on the benzene ring is going to less. Okay, the next third one, just here in this case one NO2, 2, 3. Totally how many NO2 are there? 3 NO2. Next one is what, Cl is there. Just they are going to maintain warm. Bear in mind, important, heat is different, warm is different. Warm means just slightly warm. Okay, there is no exact temperature, just make it a warm, add water molecule, automatically we are going to get a 2,4,6 trinitrophenol. This is important, 2,4,6 chlorobenzene is converted into what, important, this is bear in mind, what is the name of this one, 2,4,6 trinitrophenol. Okay, most important in this case, because the more number of electron withdrawing group, automatically the temperature is less, almost warm condition, there is a formation of product is 2,4,6 trinitrophenol is the product. Okay, is it clear? Okay, all these reactions are most important in examination. After that, mechanism is there. Mechanism is not important for PU board level, but that is most important for what, entrance exam. Next we are going to study about what, mechanism. The mechanism of what, nucleophilic substitution reaction. Okay, if you want you can take a screenshot, I will clean the board. Okay, how to take, no problem, screenshot. Okay friends, okay, the next point is what, important, mechanism of nucleophilic substitution reaction. Okay, mechanism of nucleophilic substitution reaction. Okay. First point is what? Orthonitrochlorobenzene. I am going to consider first point is mechanism for what? Orthonitrochlorobenzene. Okay, just here I am going to write the structure of orthonitrochlorobenzene. Just here, this is I am going to show the double bonds because I am going to write a mechanism. Okay, that is why this is orthonitro. Just here I am going to write like this. This is arrow mark. Okay, this is having what? 2 electrons. 1, 2, 3, 4, 5. The nitrogen surrounding, how many electrons are there? 5. That is basic. Okay, how to write electron configuration? Finally, you are going to get outermost valence shell electron. That is indicate a number of electrons surrounding on atom. Okay, just here orthonitrochlorobenzene. This is ortho position. This is chlorobenzene. Orthonitrochlorobenzene. Okay, alphabetical order naming. Okay, next. After that, in this case, this is OH minus is act as a nucleophile. Our aim is this nucleophile is going to attack on this orthochloronitrobenzene, our target. Okay, just here in this case you have maintained what? Some of the condition. Compulsory you have to maintain what? Temperature, because only one NO2 group is there. No, if 3 NO2 groups are there, in that condition you have to maintain just warm. Okay, just here in this case my aim is this OH minus is act as a nucleophile. This nucleophile is going to attack on what? This carbon, the chlorine attached to that carbon. Next question, why this nucleophile is going to attack on this carbon? Why not this? Just here in this case, most important point is what? Electronegativity. Carbon and chlorine. Here is carbon is there, no? Next here is chlorine is there. Carbon and chlorine, out of these two, which is more electronegativity? Chlorine. Carbon is less electronegativity. Less electronegativity means what? That is obviously this is electron density is what? Less compared to what? Chlorine. The nucleophile is going to attack on what? In this case. Okay. Next important point is, when this nucleophile is going to attack on this carbon, automatically this double bond is going to what? Break. Mechanism. Okay. Next, after that, this is arrow mark indicate what? Resonance. The next point is, this is a benzene ring. You have to show double bond here. Next, in this case, one you have to show OH, another one is what? Cl. No problem. Next, after that, in this case, you have to write N double bond O as it is. This is arrow mark. Okay. Next, negative charge present on this carbon. Is it clear? This is the mechanism. This is the mechanism of what? Orthonitrochlorobenzene. Just here, in this case, 2 things are possible. 2 things possible. Means my target is most important. In this case, this chlorine is act as a electron withdrawing group. Just here, I am going to clarify that basic point also. I told, but I am going to write here only. Just here. In this case, important point is what? This Cl. Okay, friends. 4, 6, this is the what? 1 is 7. Outermost electron for halogen family is what? 7. Just here, friends, in this case 2 things are important. One is minus psi effect. Minus psi means electron withdrawing group. Next one is what? Plus R effect. Plus R or a plus M, that is mesomeric or a resonance. Okay. Just here in this case 2 points are important. Minus psi effect. Next one is what? Plus R. O or R you have to write plus M, no problem. Just here, friends. Okay. In this case, minus I is there, plus R is there. What is the role of minus I? Electron withdrawing. In this case, this Cl is act as a electron withdrawing group, but when plus R is there, that time the Cl is act as electron donating group. Some of the students are going to confuse. The Cl is what exactly? It is act as a electron donating or electron withdrawing. But in this case, minus R is there, plus R is there. Out of these two, minus I effect is a dominant. Most important, minus I effect is a dominant compared to plus R. This is most important. If minus I effect is there, 100% this Cl is act as a electron withdrawing group. The electron move from what? What is this? Benzene ring to what? Chlorine. That is why most important is what? Minus I effect is a dominant. Okay. Do not think that if this Cl is act as a electron withdrawing group means 100% it is a meta directing, but not like that. But not like that. This Cl is not having a much condition to withdraw electron. withdraw electron as like a NO2, as like a NO2, bear in mind important, but NO2 it is a strong electron withdrawing group, automatically that is meta directing, but in this case chlorine is what, ortho and para directing group, because in this case what, one is plus R effect, another one is what, minus I effect, the minus I effect is a dominant, but in this case compared to NO2 that is not that much dominant, okay, that is most important. In this case plus R is a dominant, okay, act as a electron withdrawing group, but still it is a what, ortho and para directing group. The reason is in this case here is there, just here, in this case negative charge present on this ortho position, I am going to donate this negative charge here, okay, I will show here only, better I will write one more, okay, I will write here on things, okay, after that if you want you can note down, no problem, 1 2 3, okay, right, just here. First I am going to donate this one here, after that in this case what happen, this nitrogen oxygen double bond is going to break like this, here double bond as it is, here double bond as it is, next in this case OH as it is, Cl as it is, after that in this case double bond N, next in this case O minus, this arrow mark as it is, this is one point possible, okay, this arrow mark is there, this can donate here automatically, next in this case this can donate, there is a formation of what, negative charge, one possible, okay, next in this case what, another point is there, just I am going to divide here only, if this negative charge donate here, okay, this negative charge donate here, I am going to write like this, okay, this negative charge donate here, in that time what happen, here is formation double bond, automatically this is going to what, cleavage. If you, I am going to write one more time, it is better, otherwise students are going to make confuse, okay, I am going to write here only, okay, I am going to write dicto as it is, okay, here is the double bond, this is the OH as it is, Cl as it is, next in this case what happen, negative charge you have to write, and double bond O, next in this case arrow mark oxygen, okay, here is there, just here, this one is indicate what, resonance. I am going to write this negative charge here, automatically in this case what happen, carbon carbon double bond is going to break, there is a formation of what, negative charge, okay, like this, here is negative charge possible, in this case what, OH is there, next one is what, Cl, next in this case what, N double bond O, next this is the oxygen, okay, this is one thing, this is a negative charge. Next after that what happen, this negative charge donate here, automatically what happen, this carbon double bond is going to break, okay. Next in this case there is a formation of final resonance, this is here a double bond, in this case negative charge, this is a OH, next this is a Cl, next in this case N double bond O, next one is what, this is what, oxygen, okay, is it clear, okay, this is the what mechanism up to this. Finally in this case you have to donate here, automatically Cl will go out, there is a formation of product is double bond, here is double bond, final is what, OH, next in this case direct I am going to write NO2, orthonitrophenol, case closed, no, this is the indicate what, mechanism, okay, this is what, only one mechanism, orthonitrochlorobenzene, next is there para-nitrochlorobenzene, next one is meta-nitrochlorobenzene. These haloarenes are not a meta directing group, these two are indicate what, ortho para directing group, that is most important point, because in this case this chlorobenzene is having ortho para directing group. The reason is very simple, the negative charge present on the ortho and para position, not on the meta position, this is important. In this case just here, if you want you can check here, the negative charge present only on what, ortho, and next one is what, para, just here ortho is there, no problem, next just here para, next one is what, ortho, that is most important. If you want you can write para, that is your homework, you have to practice. I will write meta, okay, meta is some of the students are going to confuse, I am going to clear. If you want you can take a screenshot, 5 4 3 2 1, okay. Next I am going to remove this one, better, okay, where I am going to write, I will remove this one, okay. Comparison is better, you have to write in notebook, okay, make a notes. I am not going to write a para, okay, I am going to write a meta. Para is very simple, you have to write. Next is what, meta directing, meta nitro, chlorobenzene, no, heading, okay. Okay, just here in this case means I am going to write bond, okay, like this. In this case n double bond O, this is okay. What is the name of, sorry, what I wrote, para, no, but heading is what, meta is there, no, okay, n double bond O, next one is what, oxygen, okay, right. Next in this case what our aim is what, OH minus. OH minus is act as a nucleophile, as like only you have to take para nitro chlorobenzene, then you have to add OH minus, act as a nucleophile, finally you are going to get a result, okay. Just here in this case this is OH minus, this OH minus is going to attack on here only, no problem. Automatically what happen in this case, this double bond is going to cleavage, in this case formation, automatically in this case what happen, negative charge formation, only one, okay. Just here, this is the benzene ring, double bond as it is, here one double bond will come, here OH is there, here Cl, next NO double bond as it is, this is what, oxygen, here is what, negative charge. You have to check negative charge present on the meta position, no, the negative charge is not present on the meta position, the negative charge present on the what, ortho position. That is why this chlorobenzene or halobenzene, you have to take a complete word, halobenzene will not undergo meta directing, halobenzene can undergo ortho and para directing. The reason is what, this is the reason, entire mechanism is what, reason, okay. That is why in this case the negative charge present on the what, para, not on the meta. If by chance the negative charge present on the meta, means in this case you have to donate here, automatically this bond is going to cleavage, okay, like that in this case not possible. So that is why the final conclusion of this one, you have to write para, no, I am not going to write, okay, because the video is going to very lengthy. So you have to practice para nitrochlorobenzene. I have wrote two things, one is ortho, another one is meta. The final conclusion is halobenzenes. Halobenzenes can undergo ortho and para directing group, not a meta directing group. Totally final conclusion is chlorine is act as a electron withdrawing group, okay, because in this case minus I plus R is a, the dominant is what, minus I effect. Okay friends, subscribe and share, promote the channel. Thank you.